In this video, I'm going to describe how you draw Lewis dot structures. So remember that electrons are found outside the nucleus, and they're organized into orbitals or electron shells at different energy levels. The periodic table shows these 7 energy levels by 7 rows. Each energy level can hold a particular number of electrons. For example, level 1 holds 2 electrons and only 2. Level 2 energy level can hold 8 electrons. Level 3 can hold 18. We're not going to worry about the higher levels in this introductory course. And we typically use the Bohr model to show the electrons in their energy level. The Bohr model is illustrated here for neon with its 10 electrons. We have 2 of them in this first energy level and then 8 in the second energy level. Of all the electrons, the ones we really want to focus on are the ones that are known as the valence electrons. And these are the ones that are found in the highest energy level or farthest away from the nucleus. So in this example of drawing over here, we have 1 valence electron shown in red, and there are 10 valence electron or 10 core electrons then surrounding the nucleus on lower energy levels. These valence electrons are important because they determine how an element reacts. And elements that have similar valence electron structures will react in similar ways. And that's what allows us to put elements into the same family or the same column on the periodic table, because it's based on how they react, and how they react is based on the number of valence electrons. So the periodic table can be used to determine the number of valence electrons looking at groups 1 and 2, these first 2 groups over here on the left, and groups 13 through 18, the one sort of the other tower block, if we think of this like a castle, on the right. In the middle here we have the transition metals and our rare earth metals, and they have more unique ways of how to organize their electrons, and they're not quite so easy to classify. But you can see from the numbers that are written in these columns on this particular illustration, everything in group 1 has 1 valence electron. Elements in group 2 have 2 valence electrons. Typically, the elements we are concerned with in group 13 have 3 valence electrons, and then 4, 5, 6, 7, all the way down to our noble gases, where everything except helium has 8 valence electrons. Helium, of course, only has 2. So the Lewis dot structure or Lewis dot diagram gives you a visual representation of the valence electrons for any particular element. And these electrons are shown as dots around the atomic symbol. We're going to use Lewis structures for determining the molecular structure, the structure of the molecule of a particular compound that's formed by combining 2 or more elements. And we'll be getting into that as we move into this particular unit. So for example, we have our sodium with 1 valence electron, carbon with 4 valence electrons, chlorine with 7 valence electrons, and then neon with 8 valence electrons, shown by Lewis dot diagrams. The rules for writing these Lewis dot diagrams are fairly simple. You start with writing the atomic symbol because the electrons are shown around the atomic symbol. And you use the periodic table to determine the number of valence electrons that are present in that particular element. You want to think of your symbol as being inside an invisible box, so that there are 4 sides surrounding the atomic symbol. And so you're going to place a dot for each electron on the sides of the box. You start putting just 1 per side and then go around the box. So if you have more than 4 electrons, you're going to go all the way around with the box before you start putting 2 electrons on any particular side. So let's do some examples. Magnesium. Let's think about what is our Lewis structure for magnesium. Well, we start with writing the atomic symbol, which is Mg. And we see magnesium here is in group 2, which means it has 2 valence electrons. And so we're just going to start and can put a valence electrons here on the top side and put 1 over here on the right side. It really doesn't matter which side you start on, but remember you're going to want to, go from one side to the next side all the way around the box before you double up. So you wouldn't want to put 2 electrons next to each other for magnesium. That would not be correct. You want to have these 2 electrons separated. How about aluminum? What's our atomic symbol for aluminum? It is Al. Where's aluminum on the periodic table? It's over here in group 13. So that's our group that has 3 valence electrons. So again, we can start at any point. Here, I'll start over on we'll say the east side, and then go to south and then to west to show my aluminum with 3 valence electrons. So these are our Lewis dot diagrams or Lewis dot structure. And finally, let's think about phosphorus. Phosphorus, our atomic symbol for phosphorus is just a P. We see phosphorus over here in group 15, so it's going to have 5 valence electrons. So again, we can start at any point. I guess I'll start over here. 1, 2, 3, 4. I covered my 4 sides of the box, and then we can start doubling up. That will be for 5. So that's our Lewis dot diagram for phosphorus. You'll have time to practice this for individual elements and ions, and then we'll go on to putting 2 elements together to make a compound, showing how they will actually form the molecular structure using these Lewis dot diagrams as the basis.